Welcome back to our Spring Boot tutorial series. Today, we're diving deep into two cornerstone concepts of the Spring framework: inversion of control and dependency injection. These concepts are not just buzzwords, they are fundamental to writing decoupled, easily testable, and maintainable Java applications. Inversion of Control IoC. IoC is a design principle where the control of objects or portions of a program is transferred to a container or framework. Traditionally, in an application, your code controls the flow of execution. With IoC, this control is inverted. The framework controls the flow, and your code is plugged into it, responding when the framework requires. To understand inversion of control by example, let's compare it to organizing a trip. In the traditional approach, you plan every detail, from routes to accommodations. This method involves selecting and booking all accommodations, deciding on the specific routes to take, and even planning meals and activities for each day. The aim is to minimize uncertainty and ensure a smooth, predictable experience. This is similar to how objects traditionally manage their dependencies. Now, imagine using a travel agency. You specify your destination or preferences, and they organize everything. This is IoC. The control over planning is inverted from you to the agency, akin to how Spring manages object creation and interactions. In traditional programming, the flow of the business logic is determined by the objects that are directly instantiated and called by the program. IoC inverts this flow by having an external entity, like a framework or container, take control of the instantiation and calling of objects. This means that the details of how dependencies are created and injected into classes are handled by the framework rather than by the classes themselves. Spring configures everything for you and provides a fully ready system. Spring Boot simplifies the process of working with the Spring IoC container through auto-configuration, but it also provides several ways for you to manually define your beans and their injection into your application. Primary methods for configuring beans in Spring Boot. Annotation-based configuration. Java-based configuration. XML-based configuration. Although less common in Spring Boot, XML-based configuration is still supported. It allows you to define your beans in an XML file. This method is usually used for legacy applications that are being migrated to Spring Boot. These days, many developers choose Java-based configuration or annotation-based configuration for their Spring applications. In this tutorial, we will cover only Java-based configuration and annotation-based configuration. Dependency injection. Now, let's talk about dependency injection, a specific form of IoC. DI allows you to define how and where your classes should be instantiated and how they should be connected. Instead of your objects creating their own dependencies, they are provided by the framework at runtime. Now, to understand dependency injection by example. Using the travel analogy. Imagine the travel agency not only plans your trip but also provides you with a car filled with gas and a pre-programmed GPS. This is DI. Instead of you assembling your resources, they are given to you ready to use. In software terms, Spring Boot injects objects with their dependencies, making them ready for use without the need for manual construction. Dependency injection is a design pattern used to implement inversion of control between classes and their dependencies. It allows a class's dependencies to be injected at runtime rather than the class itself creating them. This improves code modularity and readability, makes dependencies more explicit, and significantly eases the process of testing and managing changes. Types of dependency injection. Constructor injection. Setter injection. Field injection. Spring generally recommended to use constructor injection or setter injection instead of field injection for various reasons we will discuss in separate video. From traditional Java to Spring Boot. In a traditional Java application, a book service class responsible for book-related operations might directly instantiate a book repository class to access the database. This tightly couples the two classes, making testing and maintenance difficult. With Spring Boot, we leverage IoC and DI to decouple classes. Instead of book service creating an instance of book repository directly, Spring injects it, simplifying maintenance and testing. If a new implementation of book repository is introduced, there is no need to change the code in this class. Spring will inject the required dependency at runtime according to our configuration, ensuring the code works as intended without manual adjustments. Let's discuss some advantages of IoC and DI. Decoupling of components. IoC and DI facilitate loose coupling between classes and their dependencies. By injecting dependencies rather than hard-coding them, components become less dependent on each other's concrete implementations. This decoupling enhances modularity and makes the system more flexible to changes. Ease of testing. With DI, it's easier to replace dependencies with mocks or stubs for testing purposes. This allows developers to write unit tests for components in isolation, ensuring that tests are focused, fast, and reliable. Testing components in isolation helps in identifying and fixing bugs more efficiently. Improved code maintenance. Decoupled code is easier to maintain and update. Changes in one part of the system are less likely to require changes in other parts. This isolation of components reduces the risk of introducing bugs when making modifications or adding new features. Flexibility and reusability. Components designed with IoC and DI in mind are more reusable because they can be easily repurposed or moved into different environments or applications. This flexibility also means that the application can adapt more easily to new requirements or technologies. Configuration and scalability. IoC allows the configuration of component dependencies to be externalized from the component itself. This externalization can lead to easier configuration management and scalability, as changing a component's behavior doesn't require code changes, just alterations in the configuration. Simplified dependency management. In large applications, managing dependencies without IoC and DI can become complex and error-prone. IoC containers manage the lifecycle and configuration of application objects, reducing the complexity of dependency management. Enhanced application integration. With IoC and DI, integrating various components or external systems becomes more straightforward. Since dependencies can be injected at runtime, integrating new systems or services can often be done without altering the existing codebase. Promotes good design practices. Using IoC and DI encourages developers to follow good design practices, such as programming to interfaces instead of implementations. This adherence to design principles promotes a more stable and robust application architecture. Support for aspect-oriented programming. In frameworks like Spring, IoC facilitates the use of aspect-oriented programming (AOP) to separate cross-cutting concerns, for example, logging, transaction management, from the business logic. This separation further enhances the modularity and readability of the code. Better resource management. IoC containers typically manage the complete lifecycle of objects, including creation, configuration, and destruction. This management can lead to more efficient resource use, as resources can be allocated and freed up systematically. In summary, IoC and DI significantly contribute to creating a flexible, maintainable, and testable codebase. They allow developers to build systems that are easier to extend and adapt to changing requirements, which is invaluable in the fast-paced world of software development. Don't forget to like, subscribe, and hit the notification bell to stay updated with our latest tutorials. Share your thoughts and questions in the comments below. Until next time, keep learning and keep coding.